The working principle of magnetic rings. Magnetic materials topic. A magnetic ring is a ring-shaped magnetic conductor. It is a magnetic component used to suppress electromagnetic interference. It is often used in various electrical equipment. It is usually made of magnetic materials, such as ferrite and neodymium iron boron. It has the advantages of high magnetic permeability, high saturation flux density, and low cost. The working principle of magnetic rings can be explained from two aspects: electromagnetic induction and electromagnetic energy transfer. First, when current is passed through the coil passing through the magnetic ring, a magnetic field will be generated around the magnetic ring. The magnitude and direction of the magnetic field are determined by Ampere's loop theorem. That is, the magnitude of the magnetic field is directly proportional to the current in the coil. When the current passing through the magnetic ring coil changes, the magnetic field will also change accordingly, according to Faraday's law of electromagnetic induction. The change of the magnetic field will generate an induced electromotive force in the magnetic ring. The magnitude of this induced electromotive force is determined by the rate of change in the magnetic field. That is, the faster the magnetic field changes, the greater the induced electromotive force. The working principle of a magnetic ring is based on the changes in the magnetic field and the interaction between the magnetic field and the current. To achieve electromagnetic induction and energy transfer, it has significant application value in the field of electronics. Magnetic rings have different impedance characteristics at different frequencies. Generally, the impedance is very small at low frequencies. However, when the signal frequency increases, the impedance of the magnetic ring becomes very large. This causes the energy of high-frequency noise interference to pass through magnetic materials. It is converted into heat and dissipated, thereby hindering the transmission of high-frequency noise interference. Next, let's take a look at the circuit equivalent model of the magnetic ring. Where R is the equivalent resistance of the wire loss and L is the actual inductance value of the magnetic ring. The letter C represents the equivalent capacitance between the magnetic ring coils. The equivalent model of the circuit after winding the magnetic ring is similar to that of an inductor. Let's take a look at the impedance frequency curve of the magnetic ring. When the magnetic ring is unsaturated, as the frequency increases, the higher the corresponding impedance, the more when the frequency exceeds the resonant point, the impedance will show a downward trend. That's all for today's content. If you want to learn more about electromagnetic compatibility technology, welcome to follow High&Low. Remember to like and save to keep the knowledge well stored. You're also welcome to share it with friends who need it.